Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, solving systems of linear equations by graphing. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 9th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is only going to have 2 examples, so leave a like, smash the subscribe button, and let's get started. So today we're going to be solving some systems of linear equations, except we're going to be using graphs. And instead of trying to freehand this on my whiteboard, I thought it might be better to actually do a little bit more fine tuning with some graphing paper. However, I don't have any on hand, so I use this free tool that I found online. Now, if you're interested in using this free tool for yourself, I'll put a link to it in the description box below. But before we jump into actually solving these systems of equations, let's talk about what it means to solve them, especially when talking about graphing. Now, when we have a system of equations, in order to say we've solved it, we have to find a pair, an xy pair, especially if it's a linear like this, an xy pair that works for both of your equations. And what that means is that when you plug in your x and y, it satisfies both of them at the same exact times. The same x and y satisfies both equations at the same exact time. Well, what does that mean graphically? Let's think about it this way. If you have 2 equations and the same x and y solves both of them at the same time, then that's probably going to give you some sort of intersection. This intersection is what you're looking for when you're solving this graphically. If you can find a point of intersection, that's going to be where your solution is. Now, if you intersect with linear equations, you're either going to intersect once or infinite number of times. It's not until you get into higher degree polynomials where you can intersect more than once, but less than infinity. So now that we've gotten that out the way, let's jump into this example in which we try to find where our solution is going to be. So we have a system of linear equations here. Our first equation is y equals 4x plus 3. Our second equation is y equals negative x minus 2. Now I'm going to give these different colors just to make sure that we can see the difference between them. So let's put let's say a blue here. How does that blue look? Let's put a blue. Maybe not a blue. Let's go back. Let's have a red, and we'll make it a little bit bigger as well. So you can change the size here. Let's put a red. All right. So red is going to be that one there, and let's say we get a green going. Here. So how does green look? Maybe not green. Let's try it looks like a burgundy. How does that burgundy look? Sure, we'll go with that. So we have our top equation is going to be this 4x plus 3, and our bottom equation is going to be this negative x minus 2. And those are going to be the legend, our colors assigned to those equations. So because I already have this color chosen, let's graph what this negative x minus 2 is going to be. Now you don't have to have an idea of where this intersection is going to be. Just graph them and see where you fall. So we have negative x minus 2, and we know that when we're graphing, we can start easily at our y-intercept, which is going to be this negative 2. And then our slope is going to be this negative 1. So we're definitely going down. So we can go from here and 1 here, and another one here, another one here, another one here. But just keep going down by 1, right? And we can do the reverse. So up here, the fun part of having graphing paper, you can easily see where you need to be going. So let's say this is our negative x minus 2. Now we want to go to our 4x plus 3. So we're going to start up here, and we're going to figure out what our 3 is going to be. 1, 2, 3, right? So we start here, and our 4x says that we want to go where? So we want to be increasing. So this is going to be increasing. And we're going to do 4 over 1 essentially. So our rise over run. So we're going to go up 4. So 1, 2, 3, 4 over 1. All right. And same thing down here. We're going to go down 4 over 1. Right. So 1, 2, 3, 4 over 1. And you can kind of stop there because we've hit the graph. However, let's do another one. 1, 2, 3, 4 over 1. Now we've graphed our two equations, and you can see very easily where our graph is going to intersect. We're going to have x equals -1 and y equals -1. And of course we can make that really big if we want. So as big as you need. Boom. X equals -1 and y equals -1. That's what's going to be our solution. Now we can test it out, right? So let's plug in -1 into our top. What do we get? We have -1 times this 4. So it gives you a -4 plus 3. That gives you -1, right? Boom. That's exactly what you expected. If x is -1, y should give you -1. How about your bottom? Let's plug in your -1 for this x here. That -1 times this negative up here gives you a +1, but you're going to be subtracting 2 from it, back to -1. So your xy solution works for both of these equations, and you can see it very clearly by this intersection point. So this is going to be our first example. Let's move to our second example, and let's assign some colors. So we're going to have our red again for our top one. So this is going to be our first equation, and we're going to go back to this like burgundy looking one, and that's going to be our second equation. And we're going to do the same exact thing that we did before. We're going to graph them both and see where we end up. So since we're already at burgundy, let's start with our bottom. That's a negative, if you can't see that, it's a negative 1/2 x plus 3. So let's first start with our y-intercept. We have plus 3. So up here, 1, 2, 3. And we have a -1/2 for our slope. So we're going to be going down, and it's going to be rise over 1, right? So going down 1 over 2. Down 1 over 2. Oh. Down 1 over 2. And let's do a little bit on the reverse end. So instead of going down 1 over 2, let's go up 1, back 2. Up 1, back 2. All right, so that should be pretty good for our second equation. We can do more if we need. Let's go to our first equation, and we're going to do the same thing. Let's start at -4. 1, 2, 3, 4. And we have a 3x, so we're going to be increasing, right? And it's going to be rise over 1, 3 over 1. So we're going to have up 1, 2, 3 over 1. Up 1, 2, 3 over 1. And once again, you could stop here, but let's just do one more. Up 1, 2, 3 over 1. Boom. Now we have graphed both of our equations, and we see another point that is our intersection point. This should be what we would call our solution. And what's that going to be? If I had to write that as a solution of x and y, x is going to equal a positive what? 1, 2. X equals positive 2. Y equals what? I definitely counted your y for x, but same thing. 1, 2, and 1, 2. So y equals 2 and x equals 2. That's going to be our solution. Now let's plug it in to see if it truly is going to work the same. So if we plug in 2, we should get 2 for our y. So plug in 2. 2 times this 3 is going to give you 6 minus 4 equals 2. Works. How about this one? If we plug in 2 here, we have a 2 times this -1/2. Well, that 1/2 times 2 is going to give you a 1, and it's negative now, so it's a -1. And when you add -1 to a positive 3, you're going to get left with 2. So it works for both. This is our solution. We've solved this system of linear equations. This is our intersection point, and we did it by graphing. So I hope you were able to follow along with today's video, and I hope you now understand how you can solve your system of linear equations by graphing. However, if you have any questions about what we saw today, or even on homework, feel free to put it in the comment box below, or visit me on Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, hit that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Senpai.